Okay, angle properties of circles. Um, if I just say that we have to study the properties of circles, or maybe the circle properties, so that would be better. Okay, now these properties of circles, basically they are divided into uh, some parts here. First of all, you must know that what are the symmetrical properties of the circles. Okay, we have the symmetrical properties, then we have the angle properties, and then you will have the cyclic quadrilateral segment. Okay, and then you will have the tangents on a circle. Okay, so this is a big chapter. So we are going to start from the symmetrical properties of circles. Okay, for that purpose I will be drawing a circle here first of all. Okay, now the symmetrical, there are two symmetrical properties, beta. One is that if you have a chord inside a circle, okay, there is a chord inside a circle, and then you draw a perpendicular onto it from the center of the circle. Okay, so what happens is this chord is bisected. Now, first of all, you must know that what is a chord. A chord is a line segment that joins any 2 points on the circumference. Okay, like this AB is a chord. Okay, and then this is the center O over here. Now, the property says that if you draw a perpendicular onto the chord is bisected. Do you know what is the reason behind this? Why this chord is bisected? Yes, do you have any idea why this chord is bisected? Hmm? Okay, I give you the reason. The reason is that if you draw, I mean, if you join this O with this A, and you join this B and O together, you end up with an isosceles triangle. This is an isosceles triangle, and you should know that an isosceles triangle has a line of symmetry. Okay, so this, let me call this OM. This OM becomes the line of symmetry. That is why this is the first symmetrical property of the circles, that um, a perpendicular from the center, a perpendicular from the center bisects the chord. Okay, and you can say this in other words, that if a chord is bisected by a line from the center, and that line will also be a perpendicular onto this chord. So that is the first property over here. Whenever you have Malaika, whenever you are solving a question on the circles, you have a circle over here. Okay, and you are dealing with anything like over here. Okay, so this is really handy. This is really very handy to um, to to join the lines, like if you have center here, if you join them here, you join them here, and it is really good to have this isosceles triangle inside over here. Okay, before I go on to the problems, I should tell you um, the second symmetrical property of the circles. Okay, uh, okay, for that I will draw another box over here. And okay, now Malika, you have to be responsive. Okay, you have to respond. Okay, and you have to give me the answers to my questions. Malika, suppose uh, there is a birthday party. Okay, and there are, let's say, there are 3 pizzas. Okay, which have been ordered. Okay, now suppose all these pizzas are of the same size. Okay, now Suppose it's your birthday and you say that, okay, I will, like you have a ruler with you, okay? So you keep a ruler on the first pizza like this. This is the ruler over here. And then you put, there's the same ruler over here, okay? And then you put the same ruler onto the third pizza like this. Now, imagine that all these three pizzas are of the same size, and this line segment, let me name this. Suppose this is AB over here, okay? This is CD over here, and this is EF over here. Now, suppose these lines, they are all of the same size, and the circles have the same radii. So what do you think that if this is the region 1 over here, and this is the region 2 over here? By the way, this is called the minor segment and this is called the major segment. This is the minor segment and this is the major segment. This is the minor segment and this is the major segment. Okay. Now, can you tell me, what do you think about the areas of the minor segments in all these three circles or in all these three pizzas? What would you say about that?
It will be the same.
They will be the same. Okay. And what would be the about the areas of the major segments? Hmm? They will also be
The
the same. Okay. So from here, you just remember this because this will be coming into the next properties as well. That you can I mean note it down that this is just a property that I have developed, that the equal chords divide the circles. लिख लो इसको. Equal chords divide the circles, and I will be writing in the brackets with the same radius. Equal chords divide the circles equally. Okay. So this cannot be the case that if the lengths of A, B, C, D, and E, if they are same, this is not possible that here the region 1 would have a different area from the region 1 over here, okay? So if I shade this red, okay, so all these red parts are the same, okay? Now, the second symmetrical property tells us that if you have equal chords, then they are equidistant from the center. So the center here, okay? So this distance and this distance, they are going to be the same, okay? Now imagine, Malaika, if I draw like this length is AB, if I draw the same line over here, I mean the same length line over here inside the same circle, okay? Can I say that, uh, can I say that this is also going to be the region 1? Like you have the ruler, you place it anywhere on this pizza. So if the area between this ruler and the arc is 1, so shouldn't it be the same if you place the same ruler on this side? Yes? Yes or no?
yes.
Yes, okay. So if this is the center and I determine this distance over here, so if this is the point, let's say I take this as mark this as point M, this is the point N. So this OM should be equal to ON if this region is same as the other region, okay? So the property states that equal chords are equal chords are equidistant from the center. From the center. Okay. There is one more way of proving this identity that equal chords are equidistant from the center. Okay. Let me try that with you. Okay. Now suppose, Malaika, I beta join this like this and this with this, okay? And I'm going to join um, this O with point here, and this is going to be over here, okay? And let me name this as the triangle OPQ, okay? The triangle OPQ. Now, can we say that, with all the reasons that we can give, that uh, that this triangle, let me erase all of them. Okay, now, can I say that the triangle OAB, the triangle OAB is congruent to the triangle OPQ? Can I say that, Malaika? Look
Yes.
at this. Look at this. This is the radius. This is also the radius. So OA is equal to OQ. Okay. They are both equal to the radius. Then OB is equal to OP, that is also the radius. And we already know that AB is equal to PQ. This is given to us, okay? So when you have three measures equal to each other, so that would mean, yes, the two triangles OAB, they are congruent to each other, okay? That is because of the side, side, side. When two triangles are congruent, then all of their corresponding measures, they are same. So OM inside this triangle will be equal to ON inside the other triangle, because the two triangles, we have just shown that these two triangles are absolutely congruent to each other. Okay, so we have discussed so far the two symmetrical properties. Please remember, we have done the symmetrical properties of the circles. The first property says that, the first property is that uh, perpendicular from the center, a perpendicular from the center bisects the chord. Remember this. And what should be uh, going in your mind while recalling this? That isosceles triangle, okay? Isosceles triangle, okay? And the second property says that equal chords are, if you remember these properties, you will be learning the next properties more easily. Equal chords are equidistant from the center. Okay, beta. Now let's go back to your questions. Let's see what do we have there. Okay, I'm going to clear all of them. So here is the question. Okay, now one by one, I'll be telling you quickly, and then you will be trying these questions yourself. Okay. Now look at this first question. Uh, you see that this is 5 over here. There is 13. So this is also going to be 13. And this is because you can see that there is an isosceles triangle over here. Okay. Do you see that there is an equal mark over here? It means these two chords, they are having the same distance from the center. So their distance from the center is equal. So that would mean that these chords have to be equal. So the second property, that equal chords are equidistant from the center, okay? And equidistant chords from the center, they are going to be equal as well. So you can say that this A is going to be 12. Okay? What would be this angle B here? Hmm? Yes, Malaika? If these two lengths are same, then there should be a right angle over here, okay? So this angle B has to be right angle. So whenever we determine the distance from a point, it has to be the perpendicular distance. Please ask me if you think that you're not getting these questions right, okay? Now look at this B part. I would first of all like to draw perpendicular over here, okay? When I draw this perpendicular, what will happen to this length? Yes, Malaika? What will be this length then?
Uh,
Suppose if I draw this line over here, so all of this is 16.
I they'll be equal.
will be halved, okay? Like you will have something like this. This is the center, and this length is now 8. There is a right angle. This is the radius 17, and you have to find this angle D. So you can find this through cos D equal to, like you can say cos of the angle D is equal to 8 over 17. Yes, Malaika?
Yes.
Yes, but Asa, no, look at this. If you just join it like this, let me call this A over here. How much is the length OA? How much is this length OA? Yes, Malaika?
Uh,
What is this length OA looking like for this whole circle? Hmm? What is this 13 over here for the whole circle? What do we call this 13 of the circle? This 13 is the dash of the circle. So what would you say? Hmm? Come on. A circle is known by two things. One is the center, the other is the radius. So this is the radius, yeah. This is the radius over here. So this OA, isn't it the radius here? Bolo?
yes.
Yes. And what is the
Yes.
radius, by the way, of this circle? Hmm?
7.
17, okay. So this is 17. And now, since, can you see this right angle over here? Yes. What will happen to this
Yes.
26?
It will be halved.
Yeah, that will be half bit. So let me draw this triangle here separately. So you have something like this. This has been halved, okay? And this is 17. And this is your C over here. You can find this C through the Pythagoras theorem, okay? Now, look at this B part over here. So tell me quickly, how much is this X? Hmm? Yes? This X should be, what do these marks tell you? Malaika, bete, what do these marks tell you? This mark and this mark. What are they telling you? Hmm?
That it's equal. Both the
Can you
sides
can
are equal.
yeah, like this means that this line segment is equal to this line segment. So this line segment is basically telling the distance of these chords from the center. When the distances of these chords are same from the center, this means they are also going to be equal. So if this is 22, all of this is
It
22,
will be
and
11.
its half is going to be 11. Okay. And when we are talking about the distances, the angles should be right angles over here. Okay. Now, this a bit harder question, the C one. How can we find the E and F here? Hmm? How can we find E and F? Yes. Chalo, pehle ye batao, can I find the radius of this circle? Hmm?
Uh,
You must say yes, we can do that, because you see that if I just draw a line over here, that would be the radius. Okay, that would be the radius. Okay. So this is the radius over here. Now this is 5. This side is going to be 6. Okay. This side is going to be 6. Okay.
three,
Now if in a
5.
triangle, now how much is this side? Can I say this is 5 and this is 5 here? Yes, Malaika? Can I
Yes.
say without any working this will be 6? Look at this, 5,
Yes.
6, 5, 6. In a right angle triangle, if one side is 5, other is 6, so this is 5, so the other would be 6. Without even finding the radius, I have told you how to find these sides, okay? And then you can find this angle F using the tan, I think. Tan F would be 6 over 5. Are you clear what I told you? Look at this. Suppose, Malaika, you have a triangle like this. Now, there is a right
On
angle.
these
Look
are
at this.
these two sides equal?
Look at this. Look at this. Now this side is 7 and this side is, suppose this side is 12. Okay. Now there is another right angle triangle, and you're given that um, this side is 7. Can you tell how much would be this side? Hmm? Yes,
12.
that will be 12. Like, look at this. If you have a triangle like this is 3 here and 4 here, okay? And now this is 3 here, 4 here. Obviously, this will be 5. Let's say this is hidden, okay? Now there's another triangle, and you have 4 here. So how much would be this side here? Hmm? So
5.
this will be 3. Okay. So similarly, you have 5 here and you have 6 here, and you have 5 here. So you will have 6 over here. Okay. So without working, you could think smartly. Okay. Otherwise, you see, you have to find this radius, and you have to put the same radius here, and then you had to apply the Pythagoras theorem again, and then you could have reached the same conclusion. Okay, you try these questions again, and then I will be taking you to the questions here, to these questions. Okay, maybe we can discuss these questions tomorrow. Okay, you will have to draw these diagrams, and like before you go into this, you should try these question number 1 parts again, and then we shall do that. Okay.
Yeah.